Hello, today we will go over the functionalities of Arduino Terminal. Arduino Terminal is also known as Serial Terminal. The main reference for Arduino Serial Terminal documentation is located at this address. Okay, so let's visit the link. So this link summarizes all available functions and libraries for the Arduino platform. Okay, all Arduino platforms supports these libraries and functions. Okay, for Arduino serial terminal specific functions, it is located at this link. So let's look at the link. First, it summarizes the pins for the Arduino serial terminal. For example, column number 1 lists all the Arduino boards. In our case, we are going to use Arduino Uno. It has serial pins on D0 and D1. D0 is RX. RX means receiving. D1, which is pin 1, is TX. TX means transmitting. So the moment you plug in your USB between the computer and your board, the activities between the serial monitor or the serial terminal of the computer and the board will reflect on pin 0 and pin 1. So if you're going to measure the activities using an oscilloscope, you can probe pin 0 and pin 1. Okay. Pin 0 is RX. That means it is receiving. It is transmitting on pin number 1 because it's TX. It is receiving on pin number 0, which is RX. Okay. Other Arduino platforms have extra serial terminals or serial ports, such as Mega. We have serial 1, serial 2, and serial 3. So if you need additional serial terminal, you need to use a different board. Okay, so let's scroll down. This is a summary of all the functions available in the Arduino platform that you can use to interface with the Arduino serial terminal. Okay, primarily you have initialize functions, you have read functions, you have write functions. Okay, so let's start a new project and we'll illustrate one simple example on using the Arduino serial terminal. Okay. Okay. So let's look at File, New. Let's save it. I'm going to call it serial underscore local. Save. Okay. The process you need to go through in order to use the serial terminal is very simple. First, you need to physically connect the USB between the computer and the Arduino board. Then you need to initialize it. When it is initialized, you can start transmitting or receiving through the serial terminal. Okay, so I have prepared one example that will let users to enter data through the serial terminal, and the serial terminal can print out the incoming data. Okay, so please look at this code carefully and enter the code into the Arduino program. Okay, so I try to incorporate as much as comment so you can make sense of the code. Okay. File save. Now, line number 2, you need to define an integer which you can use to save incoming data. One integer can save 1 byte from the terminal. Okay. If you need to receive multiple bytes, you can use multiple variables, or you can use array of integers. Okay. So for demonstration purpose, I'm going to use just 1 byte. Line number 6, you need to initialize the serial port or serial terminal. Serial.begin, these are the keywords, parentheses 9600. 9600 is the transmitting speed. Default is 9600. It's very reliable. You can use faster transmission rate, but the faster you use, the faster you in the application can generate errors because the Arduino is not able to catch up with the speed. So for general application with serial terminal, we want to use 9600. That's kind of a default value. Okay. Delay 3000 is to delay 3 seconds before you do additional operations on the serial terminal. The reason we want to do that is sometimes when you connect the USB between the computer and the Arduino board, the Windows platform need to initialize the USB connection first. So this additional 3 seconds give you enough time for Windows to finish initializing the USB connection. Okay. All right. So this is a one-time operation. That's why we put it into the setup. Okay. If later you discover that the delay is not enough, you can use 4 seconds. You can use 5 seconds or 6 seconds. But 3 seconds should be enough. All right. So then let's go into the loop function. In the loop function, what you are going to do is you are going to check if any data is available. Any incoming data is available. So the function you use is serial.available. If you have incoming data, the data will be stored temporarily into a buffer. But this buffer is very small. So what the serial.available is checking if anything is available in the buffer. 0 means no data available. Anything higher than 0 means there is at least 1 data available. Okay. So if we detect there's something available, we're going to read it using serial.read and save it in this variable. Then you can use this variable to do additional processing. Okay. So what I'm going to do is, once we received the incoming byte, we're going to print out the message: I received the incoming byte. I want to print out the value in decimal format. Now pay attention to the print and the print ln. Is print ln. Print, it's like this printf in C programming, but the function do not include the \n. Print ln will include the \n. Okay, so you are in this loop, keep checking if anything is available. Okay, so practically this example is going to examine the incoming data one at a time. Every time it reads a value, it's going to print out the value. Okay, now in real applications, what you need to do is you need to put a little bit of delay, for example 1 milliseconds, such that you do not overload the CPU, which is the Arduino, by checking the buffer, okay, constantly. So this additional 1 milliseconds does not interfere with the operation at all, but it does free up the CPU to do other stuff if needed. So let's do a file save. Okay, so this is a good example. You can run this example on the board. So now let's do a tools, port, board. Double check the board should be Uno. Port should be 3. In your case, it may be 3, it may be 4, it may be 5. Sketch, verify, and compile. Okay, compiling done, no error, so this is good to go. So let's sketch upload. This program is going to load into the Arduino. Okay, so done uploading, good. So the moment you're done uploading, the program is running. So the first thing the program will do is you're going to initialize the serial terminal. So in the Arduino, the serial terminal is built into the Arduino IDE. So if you go to here, this is the serial monitor or the serial terminal. You click. If you see the color of this window is active, blue, that means the connection between the Arduino and this monitor is connected. Okay, there's a few things you need to double check in the terminal. First, if you want to see the timestamp of the incoming data or any outgoing data, you check the box. By default, there's no need to do that. Okay, speed, if you drop down, you can see that they support many different types of speed. In our case, we use 9600. Okay, all right. Okay, and this button, clear output, is for you to erase anything already on the screen. Okay, so by default, the moment you open this terminal, everything has been erased. Okay. So going back to the Arduino reference page, okay, what we can do is we can look at the functions and try to understand what we can do with the serial terminal.